Hello year 9. In this video I intend to show you how to find the formula to solve every single second degree equation or function. Okay, differently from what we've been doing on these last days, in which we've been solving second degree equations without the coefficient b. That technique that we were applying, it's not possible to solve when we have the coefficient b. So we need to find a formula, okay, and understand the steps that we're taking. Okay, the formula is this one. That you can see here in the right of this red arrow, and we're gonna start our path out of the standard formula equalized to 0. I don't know if you remember, but every single case in which we were solving that, those cases without letter b, we were equalizing it to 0. Okay, this is very convenient for us because it makes things easier. Okay, you're gonna understand why, I hope. Well, for doing so, what we need to have in mind is that some knowledges are needed. I'm gonna present to you the idea of completing squares, which is exactly what the name brings. Okay, we're gonna have a square in which a piece of it will be out, and we're gonna complete it algebraically, and you're gonna understand. Another stuff that is needed is LCM, least common multiple. You're gonna see, I'll be telling you when it's needed, but you're gonna realize that LCM will be applied. Some of our goals is, of course, isolating the x, as you were doing when we were solving those equations without coefficient b. Okay, we were always finding x equal to plus minus something. Okay, and of course, our main goal here is finding this formula. Oh my god, sorry. It's finding this equation out of this first one. Fine. Well, so to start, I'll ask you to, take notes of while I take the steps here. If it's needed, you stop the video, try to watch it again. That's why I'm making it in video form instead of having the classes, because you are totally allowed of restarting the video, watching it again if you have doubts. But don't skip your questions. Anyway, of course, I'll be totally available for you if you need something about the video I can recap. Okay. Well, then starting our algebra here. Something that we can never forget. We are dealing with an equation. So I am allowed to do whatever I want on the equation, not only in a single side, on both sides. So here I'll be dividing some things on both sides. I'll be adding things, but on both sides. Okay, so that's what you have to keep in mind first of all. And I'm going to start doing something kind of that, but I will divide both sides of the equations by letter A. And remember, A, B, and C are their coefficients, but they are, in the end, they're numbers. Okay? They're not variables. So by dividing both sides of the equations by a, the a that follows x squared will disappear because a divided by a is 1. B divided by a, x plus c divided by a. Once a is a number, you agree that when I have 0 divided by a, I'll get 0, right? So you're just getting 0 here. It doesn't matter. The only thing that a cannot be, and a can never be, is 0. So that's a rule that we have to follow. A can never be 0. First, because the first assumption that I'm doing now, 0 divided by 0, you can try on a calculator, it doesn't exist. Very good. So since A was divided on both sides of the equations and I have C over A, we don't have x multiplying in such case. So we're going to start isolating our variable, which is x. I'll get c over a, c divided by a, in the other side of the equation negatively. Take a look. See if you understand. X squared plus b divided by a, x equals to negative c over a. Okay? That's it. Now here comes the geometry to help us understand what we are doing. When we are finding area of some surfaces, we normally do side times side, okay, which gives us a number as an area. Take a look here. Take a look. This equation that I have here, I just decided to represent it geometrically. And this will be very, very helpful for us to continue our definition of the second degree equation formula. I'm going to put here beside the same equation as I have there. Let me just copy and paste. I think it's simpler. Copy. Okay. Oh my God, it shouldn't be here. Sorry. Copy. Copy and paste. It's not pasting correctly. Well, I could fix. Thank God. Okay, very good. So as you can realize, this area represents here. And if I imagine that I have a rectangle with one side being x and the other side being the measurement b divided by a, I have it here as well, because take a look, this is a multiplication, okay? And in the other side, even if I have a negative c over a, don't pay attention on that. This can be also considered mathematically as an area, and we are capable to see such geometry, okay? So by seeing it, we're gonna deal with those numbers to continue our calculus, looking for the formula of second degree equation. At this step, year 9, what we're gonna do here is applying the idea of completing squares. Okay, completing squares is a technique which helps us finding terms in math in our algebra in which are kind of hidden, and we can infer over the math, since we do on both sides of the equations, like adding things on both sides of the equation. Very good. So please take a look. I have my second rectangle. If I cut this in half here, if I cut this in half, I'll have two smaller rectangles side by side, in which I'll have the top and the bottom, they measure b over a. If I divide it by 2, do you agree that each side here will be measured b over 2a? b over 2a, okay? And when I join them back by having it as it was originally, I'll have the whole rectangle measuring in one side b over a. And the height, which we normally call like this, will be measuring x, okay? Why am I having two pieces out of one? Because take a look, they measure the same. I just put it here and I decided to cut in half. And by cutting in half, I can rotate and put on the top of this square, okay? Instead of just rotating here, I already have this piece separated just to help to get some time. And take a look. We have an incomplete square. I am able to complete the square by doing like this. So this small square, this is the small square in which I can complete my bigger one. But what are the side measurements, guys? Take a look. Here, it measures x like before, here as well. This side measures, remember, b divided by 2a, okay, because this is the measurement of the rectangle with sides as b over a, but it was divided by 2, so that's why I have number 2 there in the denominator, okay? And here measures the same, b over 2a. This side measures x, this side measures x. The area of this small rectangle is b over 2a times x. Do you agree, right? And here the same. Here the same. Let me make a better arrow. The same. b over 2a times x. This is the area of those two rectangles. And the inner one measures as seen before, x squared. Okay, so once this rectangle measures the same as this rectangle, it's normal, it's expected to be x squared its area. And of course, this other side is negative c over a, like it was before. But I told you that I added this small square together with all of those measurements that I used to have on the left side. Take a look. I'm gonna get what is the area of this new square that I added here. Firstly, I need to build the square. I hope it did pretty well. Do you agree that this measurement here is the same as this here in the bottom, and this is b over 2a? So it means that the area of this square will be b divided by 2a times b divided by 2a, because it's a square and the sides measures the same. If they measure the same, do you agree that I can represent in such way? Right? I can represent the area of that green small square as being b divided by 2a, everything, the ratio, squared. But as I said right from the beginning, anything I do in the left side, I need to do on the right side, or vice versa. Everything I do on the right side, I need to do on the left. So it's not just a matter of adding that number squared on the right side. I need to do the same here. So this is also b over 2a squared. Okay. Just to simplify, take a look. I'm going to rearrange all the algebra that I was doing before here with this mess. Let's organize my diagrams. So I'll have x squared, which is this first here, plus x b over 2a times x, which is this area, plus, again, b over 2a times x, which is this area here, plus, finally, that small square, which is b over 2a squared. What is it equal to? Everything I have on the right side. Negative c over a was already there, and it's being added to b over 2a squared. Okay, very good. Let's simplify it. To simplify this math, what I'm going to do is rearrange the numbers which are squared. Okay, well, x will be left as x squared. These two terms, they can be joined. Take a look. I'm going to put here, this will become b over a x. This third term will be, take a look if you agree, b squared over 4, because 2 squared is 4, right? Times a squared. And in the other side, negative c over a plus the same term that I just found, b squared over 4a squared. Fine. I'm going to get everything here. Take a look, I'm going to get everything, and then I'll come back there to the top. Okay, because we started our math there. Very good, copy. Let's see if we will do it. Sometimes this app doesn't help me too much. Let's see if this will be fine. I intend to put it here. Well, very good. Just that point of the area of arrow that is not. Oops. Sorry, you're dying. This is the continuation of our math. And realize that every term is here. This is here, this is here, and this is here. What I did is I added b squared divided by 4a squared on both sides. Okay? Something else that we are used to do, we've been doing this in these 2 last weeks, is what we call the binomial of the perfect square. Okay, we studied this 2 weeks ago, if I'm not mistaken. I'll ask you to stop the video if needed, check the steps from top to bottom, just to recap, and then you play it again, okay? Please do it. In such level, year 9, we're gonna do the opposite. We're not going from top to bottom. We're gonna go from bottom to top, okay, in this direction. Because if you agree, take a look. Instead of putting 9, I'm gonna put here 3 squared. Comparing with what we have there on the top, with our equation, what we have, let me see if I can put in a single frame. We have x squared, we have x squared. We have a number multiplying x. B over a is a number multiplying x. And I have another stuff, everything squared, which is this 3 squared. Remember that b and a, they are only numbers, and they are being multiplied by 4, and 4 can be represented as 2 squared, right? So by taking the previous steps, I'm going to rearrange the math in order to come back and find the following. See if you don't understand. See if you understand, I think it's better. If you understand, and if you don't, we can discuss this during the classes. Take a look. X squared will be kept like this here. We're going to have b over 2a plus b over 2a plus, and then I'll have exactly b over 2a now squared equals to whatever I have in the other side without changing it. 4a squared. Okay, we are just rearranging the left side. Okay, everything here will become as follows. X plus b over 2a, everything is squared, right? Equals to c divided by a plus b squared over 4a squared. Okay, there's a step here. If you don't get what I did the opposite as finding the simplification of the binomial of perfect square. Okay, we can discuss this during our classes if you have questions, and then we can take only this small step if needed during our moments together. Okay, year 9? Year 9, in such a level, you are almost there. You are almost finding the second degree equation formula to solve the equations, the formulas, the functions. What we have to do now is rearrange in order to find x alone. Take a look. Beside this letter, beside this x, there is no other term multiplying x. This one, no x. This one, no x. This one, no x. So it's just a matter of rearranging the math without losing track, finding the formula, the solution. So now let me just putting a line here just to divide what we did before with what we are going to do now. I'm going to take some steps, and now it's going to be needed the knowledges of plus minus in square root. Take a look. I'll have x plus b over 2a, and this is equals to plus minus the square root of everything that I have there. C over a plus b divided by b squared divided by 4a squared. Okay, got it? I just got the squared, the number squared, that term squared in the left side, and I decided to get the exponent and put in the other side. By putting the other side, it turns into a square root, and the square root becomes positive and minus. And here it starts showing both of our possibilities of answers. Okay, and now let's apply the LCM. The LCM will be applied inside the square root. A common multiple between a and 4a squared, I mean the denominators, I'm just going to copy the left side of the equation. a common denominator will become, see, I'll have a single fraction, will be 4a squared, right? And what did I do to make my letter a become 4a squared? I multiplied by 4a. So if I got a times 4a, I got 4a squared, which is this term. But in order to not unbalance my quotient here, I need to multiply negative c by 4a as well. So I'll have here in the top minus 4ac. Something that we already have there on the top of our equation. How did I make 4a squared to keep as 4a squared? It's just a matter of leaving it the way it is here. Take a look. Good. This square root can be broken into a square root on the numerator and a square root on the denominator. The square root on the denominator can be turned into 2a. Because think with me, the square root of 4a is the same as the square root of 4 times the square root of a squared. This becomes 2 and this becomes a. Okay? We can also discuss that if needed later during our class. But the following step would be x plus b over 2a equals to minus, positive minus, the square root on the top, on the numerator, cannot be changed. But we can rearrange the numbers. Let's put the positive number first. B squared minus 4ac divided by 2a. Okay. Now, our final step. What we're going to do is finally isolating the x. How? Getting this b over 2a in the right side. So I have there the square root, b squared minus 4ac divided by 2a minus b over 2a. Ooh, we have a common denominator. We can join everything. Finally, our step, our function, our formula will be negative b plus minus the square root of b squared minus 4ac over 2a. And that's exactly what I have. And that's exactly what I have here in the top. Compare both equations, guys. This and this. We took many steps. We applied many different stuff. But now we can apply every single equation over this formula. And we're going to have results. Okay? I'm going to solve finally here a small example. Okay? Just for you to see how can we apply it. Okay? And that's what you're going to do on your project. Okay? That's it here, 9. We found. Let's solve an exercise. And then the example we're going to solve here, 9, is the following. 2x squared plus 12x minus 14 equals to 0. Okay? Realize that we have coefficient a, b, and c now. Let's identify them. A is equal to 2. B is equal to 12, and C is equal to negative 14. We're going to apply all those A, B, C in this formula here. Okay, so there is no mystery. Where there is A, I'll put 2. Where there is B, I'll put 12. Where there is C, I'll put negative 14. I'm going to do in purple. I'm looking for X, right? 2, number X. 2 results, different ones. Negative b is negative 12. Follow the equation there. Here on the top of my head. Plus, minus, inside the square root, I have 12 squared minus 4 times. A is 2. C is negative 14. Do never forget the negative. This will be breaking down everything. If you don't like negative, try to make it your friend. 2a in the bottom. 2 times 2, right? Let's simplify whatever we can. Negative 12 will be kept the way it is, but inside the square root, we can put some simplifications already, following Bedlam as always. So 12 squared is 144. And if you solve that multiplication, again, negative 4 times 2 times negative 12, you're going to have positive 100 and negative 14, sorry. You're going to have 112, okay? And in the bottom, you're going to be dividing by 4. 2 times 2 is 4. Let's simplify some more things. 12 cannot be done. We're going to have the square root of 256 divided by 4. And at this step, we know that 256 is 16, okay? But we have, again, plus minus. We are adding 16, and we are subtracting 16. Pay attention, guys. Our first possible answer will be negative 12 plus 16 divided by positive 4. Negative 12 plus 16, we're going to have 4. 4 divided by 4, 1. This is our first result. X2 will be negative 12 minus 16 divided by 4. Why did I put minus? Because remember, I have positive and negative on that side of the solution. Negative 12 minus 16 will give us negative 28 divided by positive 4. Negative divided by a positive, we're going to have a negative number. 28 divided by 4, negative 7. So our two possibilities to make such equation here with those numbers, 2, 12, and negative 14, to be truth, in order for me to exchange what x is, in order to have 0 as a result, this x here and this x here can be replaced as number 1 or negative 7. So what are the possibilities for me here? X is equal to negative 7, negative 7, right? Negative 7 or 1. This is how we find. Okay? I hope you understood. We can discuss more about it, and we're going to solve a lot of those examples together. Thank you very much, Year 9.